In the last lecture, we discussed the simply singly linked list, the concept of the linked list. So we already understand that the linked list, its basic building unit is node. And a node has two parts, the data parts, so that's store the information, and the next part point to the next node. And a linked list basically is a collection of the node that's linked together. Okay, so it's a linear data structure. And also linked list is efficient at adding information and removing, but it doesn't support indexing operation. Okay, so that's the concept part. So now let's take a look at the implementation of the uh, singly linked list. So the first over here for our implementation, so it's the textbook Java linked list example. Okay, so we have two files, linked list.java files and the application of the linked list that we defined. For the linked list implementation over here, so we define it as a class, and it's a generic one, okay? Because for this linked, it's support of the items in ascending order. So in order to achieve the ascending order, uh, we make the generic to also support the comparable interface. Okay, so that when the item is inserted, then you can do a comparison. Okay. And for linked list, as we discussed in the concept part, there is only one data member, so the type is node, and we name it as first. So it's a first node in the chained linked list. And before we move to discuss about the operations of the linked list, let's first take a look the definition of the node class. So for the node class, we define it as a inner class. And also it's a classic, it's a static, so inner and static class, okay? And because it's inner class, so it can access its outer classes data members. And for this node class, and it's has two parts, the data part and the next part. And it also has a constructor, okay, to create the new node. So it will initialize the data with the provided data and the next with the provided next. So that's the node class. We define it as static inner class. And because we define it as a static inner class, okay, why we define it as a static? It's because you can also initialize to the node object without create the linked list. Okay, so that's why we put it as static inner class. And then let's move to discuss the member methods. Methods of this linked list, generic linked list class, okay? The first is the constructor, okay? Well, the constructor pretty simple, so you just, because it's create an empty linked list, so you just assign the first node to the null, okay? And we also have a member method that to check if the linked list is empty. So the empty condition is if the first node is a null value. And we also provide the overloaded function toString. Okay, so we to for this toString method, what we are going to do is we are going to return the content of the linked list as a string. So in order to do that, we first have a local variable, the type is string buffer created. Okay, it's empty. And then we use this for loop. And what this for loop does is does traversing. So it's basically a node by node visit. Okay, so it's a start at the first node. So the loop variable is node, okay, and the cursor. And it's a loop to the last node and advance with cursor equals cursor dot next, okay. And then you get each node's data part, okay, and you concatenate to the string buffer variable result and separated by the colon and the space. And then we can call string buffers to string to convert it back to string and return it. So the insert operation is, so insert is add, okay? So you add an item. And it's one of the two important operation in linked list. So here, its parameter is some item that you want to insert, but we are going to insert in ascending order as previously we uh, defined for this linked list. Okay, so there are different scenarios that we already discussed. First, if it's empty list, then you need to create the new node, okay, with this item. And its next should be null, okay? And you assign it to the first node. So that's um, this case. And we can also insert at the front. Okay, so how to insert to the front because it's in ascending order. So we are going to do the comparison. Okay, and because that T generic T, okay, it extends from the comparable, okay, so it supports a comparable interface, and this compared to is from that comparable interface. So that's why here you can call the compare to and compare with the data, okay, and here you cannot directly use the less than or greater than operator for the comparison because it's an object. Okay, so the object must support a comparable interface to be able to compare using compare to method. So if it does, and you create this new node, okay, with the item and its next is the first node, okay, create this new node and then you set this new node to the first. So that's you insert at the front. And as we discussed, you can also insert in the middle or at the back. Okay, so in order to do that, you first need to find where you're going to insert to locate the location, to find the location. So in order to do that, uh, we can create uh, a node variable, we call it a cursor, okay, to do the iteration. Okay, so here we use a while loop. And because when we do the traversing, when we do the advancing of node, okay, we don't want it to go beyond the list. So that's why we put the cursor's next is not null, so that it won't go beyond the last node. Okay, because if it go beyond the last node, then we cannot do advance. Okay, so we need to put when we do this while condition, we put this condition first instead of the comparison first. Okay, so uh, so if this condition already met, so if it's not beyond the last, so the node does exist, is it? Then you can access cursors next. So it's the next node's data part, and then you do the comparison. Okay. If the condition meet, then you can continue advance your node. And then you can find the location that you're going to insert after the cursor. So how we do that is just set the next to the new node, okay? And the new node's next to cursors next, so that you can insert in the either in the middle or at the back. It will meet both conditions. So that's the insert operation. And then next, let's take a look the remove operation. Okay, so for the remove operation and say similar, we have a couple of scenarios we needed to discuss. Because if it's an empty one, then you cannot do delete. So that's why here we just throw some exception. Okay, it's a runtime exception. Or if it is the first node you're going to remove, then you need to update the first node. So be careful about this. Otherwise, you need to find where the item is. In order to find where the item is, if you recall in our explanation about the concept, we will do the pair advancing. So for the pair advancing, so that's why you need two node variable, okay? The cursor and its previous one, okay? And then you do the loop, okay? And here, similar, you use the uh, you to access the data part and call the equal, okay, method to find if the contents are the same. We don't do the uh, equal for comparison. Equal only works for primitive type. Okay, here is object, so you need to call the equals method. So if it is not the item, then you just advance, do the pair advancing. Okay. Once you find the location, so when the loop ends, basically you find the location where you're going to remove the item. Then what we can do is you just set the previous node next, two cursors next. Okay, you delete that. But be careful if the cursor point beyond the last node. That means that item you want to delete doesn't exist in the linked list. So here we throw a runtime exception. And the next method is about the search. So this search method basically is kind of do some traversing. So this will be the knowledge check part of the work. Okay, so you can try to practice with this method. So that's regarding the linked list. And next, let's testing this linked list. So we write our testing application in this Java linked list class. So here is that main method. So in the main method, what we did is we first, so over here we create a string linked list. Okay, so as list, so the type is string linked list. Okay, and then you do new linked list. So that's our defined one. So it create an empty one, and you can check if it's empty, call its method is empty. Then we try to do insertion. Is it insert letter by letter? Okay, ZA. And after that, you can output the list. And why we can do this? Because basically it will call that toString method. Okay. And then we also try with insert operation. We also try with remove operation, and we are going to output the list to check if the item did get inserted and removed. And what the second part we did is we create an integer linked list, okay? And similar, we first check because when we just call the constructor create the linked list, it will be an empty one, so we can check, okay? Then we insert the numbers, and then we check the list to see if all the items are inserted and also in their respective order, okay? And we also call remove and check. And now we can run the program and to see, yeah. So the running result, from the running result, you can see, yeah, whenever you first create an empty, yeah, create an empty list. And after you insert, you can see, is it, so it's in ascending order. So yeah, no matter what the order you in, is always in ascending. That's what we did. And it also insert a new item, okay, at its respective location, and also remove the item. So here, this item did get removed, okay. And same thing for the integer list. Okay, integer list. So everything runs correctly. Okay, so that's the end of the discussion about the implementation of the singly linked list. So it's the simplest case, okay? And so that's the end of this lecture. In the next lecture, we will move on to discuss the linked list implementation, which also support iteration. Okay, so how we are going to do it. So see you next in the next lecture. Bye.